Okay, so we all learned how to find the area of a simple square back in school, right? But what about the real world? Most things aren't perfect shapes. So how in the world do you measure them? Well, in this explainer, we're going to unlock the secret to calculating the area of pretty much any complex object you can think of. We're just surrounded by odd shapes that seem impossible to measure. Think about a custom-built desk, or that wall with a window, or even a doghouse. None of these things have a neat, simple formula. But it turns out there is one single, really powerful strategy to conquer them all. Let's start with a classic problem. You're ready to paint a room. You know the wall's dimensions, but there's this giant window sitting right smack in the middle. You definitely don't want to buy paint for the window, right? This is the exact kind of puzzle we're solving today. It's practical. It's something you'll actually run into. And the solution? It's surprisingly elegant. And here it is, the core idea, the big secret, is what I like to call the add or subtract strategy. Now, I know it sounds simple, and honestly, it is. This one concept is the key that unlocks how to measure almost any irregular shape you'll ever come across. The best part is, we're not inventing any new math here. We're just being clever with the stuff we already know. The whole strategy is about seeing the simple shapes, the rectangles, triangles, and circles that are hiding inside the more complex ones. So this strategy really has two different flavors. First, you've got the add strategy. This is where you break a weird shape into smaller, manageable pieces and just add their areas together. Then you have the subtract strategy, where you do the complete opposite. You imagine a bigger, simpler shape and then just cut away or subtract the area of the parts that are missing. They're really just two sides of the same brilliant coin. Let's actually look at the add strategy. See this L shape? At first glance, it looks a little tricky. But if you just draw one simple line, boom, it's two simple rectangles. You calculate the area of each one, add them up, and you're done. See? It's that intuitive. Now let's try the subtract strategy. Instead of building up, we're going to cut away. Imagine a full rectangle first, and then mentally just remove that little corner piece. You just calculate the area of the big rectangle, then find the area of the small corner and subtract it. And just like that, you have the area of the L shape. Same answer, different path. All right, enough with the theory. Let's put our new secret to the test with some real-world 2D problems. This is where you're going to see just how powerful this simple idea can be. Okay, check out this mirror. It's really just a combination of a rectangle and a half circle. So we're going to use the add strategy. First, we'll find the area of the rectangular part. 36 times 50. That gives us 1,800 square centimeters. Easy. Then we got to tackle that half circle on top. Now, the area of a full circle is pi r squared. So for a half circle, we just divide that by 2. That gives us about 509 square centimeters. Add them together, and the total area is roughly 2,309 square centimeters. Simple. All right, now for a subtract strategy example. This packaging has a square cut out of it so you can see the product inside. So we start by calculating the area of the whole rectangle, pretending that cutout isn't even there. That's 24 by 20, which is 480 square centimeters. Next, we find the area of the little square that was removed. 9 by 9 is 81. And finally, we just subtract that smaller area from the larger one, leaving us with 399 square centimeters of cardboard. Done. Okay, you've totally mastered 2D, so I think it's time to level up. Let's move on to what feels like the final boss, calculating the surface area of a 3D object. I know it looks intimidating, but trust me, you already have all the skills you need. That secret strategy, it works here too. So meet our challenge, a custom doghouse. It's got a square body, a peaked roof, and a cool curved entrance. Our job is to figure out exactly how much wood is required to build it. This is what we call a composite object. It's just made of several simple shapes all joined together. So let's break it down. The key to not getting overwhelmed with something like this is just having a good plan. We're going to treat this doghouse like a puzzle, calculating the area of each face one by one. So we have the front, the back, and the two sides. And this is important. Notice the crucial detail. There's no bottom face. The doghouse sits right on the ground, so we don't need to waste wood on a floor. Let's start with the front. The front face is actually a great mini problem all on its own because it uses both of our strategies. We start with the 1 by 1 meter square base. To that, we add the triangular roof peak. Then, we subtract the half circle opening for the door. So we add the square and the triangle, then subtract the opening, giving us a final area of about 1.05 square meters for the front face.
Phew. Okay, the back face is way easier. It's basically the same as the front, a square plus a triangle, but there's no opening to subtract. So we just add the area of the 1 meter square and that triangular peak, which comes out to 1.15 square meters. Look at that, 2 faces down, 2 to go.
Now for the sides. Each side is made of 2 different rectangles. You've got the lower wall and then the slanted roof piece. We add their areas together to get 2.4 square meters for one side. And since both sides are identical, we just multiply that by 2 for a total of 4.8 square meters for both of them. And now for the gram total. We just need to add up the area of all our faces, the front, the back, and both sides. That's 1.05 plus 1.15 plus 4.80. And the final answer is exactly 7 square meters of wood. We did it! We took a complex 3D object, broke it down, and measured it piece by piece. But why does this even matter? Well, because 7 square meters isn't just some abstract number. It's a budget. If wood costs $4.89 per square meter, we now know this project is going to cost exactly $34.23 in materials. This is how real-world projects are planned, from doghouses all the way up to skyscrapers. So, you've seen the strategy in action. Now, let's talk about how to really become a master and avoid the common traps that can trip people up. Think of these as pro tips to make sure you get it right every single time. First up, this is the most common mistake people make with circles. The formula for the area of a circle uses the radius, which is only half the distance across. But a lot of problems will give you the diameter, the full distance across. So the question is, are you remembering to cut that number in half before you start squaring? Seriously, using the full diameter by mistake gives you a wildly incorrect answer. The right way is to always find the radius first. So if the diameter is 36, the radius is 18. It's such a simple step, but forgetting it is probably the #1 source of errors. And here's the second classic trap, which we saw in both our mirror and doghouse examples. It's so easy to get excited about calculating the area of the full circle that you forget you only needed half of it. Just remember, if you're dealing with a semicircle or a half-circle arch, you have to divide that final circle area by 2. And finally, just a couple of quick sanity checks. Always reread the problem to see if any faces are open or missing, like with our doghouse floor. And before you write down your final answer, do a quick logic check. If you subtracted a piece, did your total area actually get smaller? If it didn't, you probably made a simple sign error. It's a super quick way to catch a mistake. And there you have it. You now have the secret. The add or subtract strategy lets you look at any complex shape and see the simple, measurable pieces hidden right inside. You can now measure, plan, and build with confidence. So the only question left is, what are you going to build or paint next?